That should be all for me today. So it's 2 o'clock on the dot. I will pass things over to Tara O'Hare from EPA to get things started.
Thank you so much. Welcome, everyone. Thank you for joining us today. I'm here with Anneke Chamberlain, who's the founder of Mimere Water, to equip water efficiency professionals and property operators with practical solutions to eliminate the financial and environmental cost of water waste. Anneke specializes in integrating solutions into existing operating procedures so water efficiency becomes part of daily routines. In addition to working directly with water providers and businesses, Anneke provides training courses and works to develop tools that make water efficiency easier to achieve. She recently launched a water assessment mobile app and an ultrasonic clamp-on submeter equipped with high-resolution cellular reporting technology. Anneke loves talking shop, especially when it comes to cooling towers, and is guaranteed to have at least one submeter in her bag at all times. Anneke has a bachelor's degree in watershed science from Colorado State University and a master's degree in climate science and solutions from Northern Arizona University. I'll pass things over to Anneke.
Great, thanks, Tara. Well, welcome everybody. Today we're going to talk about effective submetering strategies for commercial properties. Obviously a very big topic, but we're going to try to look at as many applied projects as we can, as many case studies as we can. I work a lot with commercial properties, typically through conservation programs, municipal conservation programs, and some facilities training. So we'll get right into it. So commercial properties, they're big, they're unique. One restaurant is not the same as another restaurant. You can go from a grocery store up to a hospital, up to a campus, right? So they're a bit black box, especially when we're looking at kind of the standard main municipal meter. So basically, you can't really tell what's going on, and the bigger it is, that monthly bill doesn't tell you too much. And even with AMI coming out, even an hourly rate doesn't help too much when you get to really large facilities. So what can we do to help this? We can add submeters, but guess what? It's still a black box unless we're actually going to use that submeter information to help us operate. So a submeter isn't very useful unless we're actually using the data. So once we add data management, things are starting to come alive now. We can see what's going on in the building. We can see what's going on in the irrigation system. We can see what's going on in the cooling. So now we're starting to tease this water use apart, start to get a property water balance. But if we can take those submeters and have high resolution water data, we have entered the matrix. It's amazing. Tells you so many things of what's going on. It's not just the volume, it's the signature of the equipment and the use that's really going to help us understand what's going on. So the number one thing with a submeter program, with any submeter, it has to be value added. Commercial properties are very busy doing business. They have processes, procedures put in from years to decades to maintain and achieve their business goals. Managers are managing, operators are operating. Management, very busy. These guys answer sometimes over 500 emails a day. They're looking at budget, lots of management things. And then we have operations, right? They're basically responsible for keeping the property running. So a submeter program has to make life easier for ideally both, but at least one of these people, because if it sends them chasing their tail or it's cumbersome for them, it's not going to be effective. So it needs to provide useful, actionable information. And we're going to look at a lot of case studies on how that is. So we need to make sure that we're looking for outcomes, right? So what's a desired outcome? So ideally, people want to get flow rates. We want to isolate a water use area, maybe a piece of equipment. So that's nice. That certainly helps. But what if we can take it beyond that? We're identifying mechanical failures, diagnosing operational adjustments. You know, what is how efficient are things running? Not just are they running, but how efficient are they running? A great one, we'll look at some case studies on, can we quantify costs for payback? What are hotspots? You know, I've got increased water bill. Where's that water going? What information do I need to upgrade a piece of equipment, to change a procedure, something like that? And then very important to verify service provider performance. So by service providers, could be the landscape technician, it could be the cooling tower, water treatment provider. There's all kinds of them. And the more complex facility, again, a hospital, a campus, you're going to have any number of these. And so it's really good to be able to have a pulse on how they're performing. So if you don't know where to start, number one place to always go in life in general is to follow the efficiency hierarchy. Now, I live and die by this thing, and anytime that I just kind of jump ahead, I pay for it. So first off, what is the mechanical health of the system? Is it operating as designed? Because it doesn't matter what you do if it's broken, it's not going to, nothing is going to help it except fixing it. So this could be a physical break, like a broken pipe, but oftentimes it's a failed valve. If anybody's had any of my trainings, no, you can never trust a valve, they will always fail. So mechanically, is it running as designed? Okay, next step, let's say, well, operationally, what are my settings? These are adjustments. Can I make an adjustment that gives me added value with no additional work? Basically, is the equipment efficient? This is irrigation, cooling towers. Is it running efficiently? Okay, our mechanical and operational are in order. So now what can I do to maintain those systems? They're constantly trying to get out of efficiency, or there's always mechanical failures. So can I use this submetering to keep these things in track over the long term? So then finally, what I would consider that bulk is water management. Okay, now we've got a good water management system in place. Now we can start looking at paybacks. What's that upgrade that I can do? I'm really going to get a return on investment. So for like a cooling tower, you might think, oh, let's put in a water softener and we're going to be more efficient because we take all the minerals out. But if you're constantly having mechanical failures, your set point is way too high or way too low, you're never going to achieve that ROI. So always trust the efficiency hierarchy. Okay, so let's get into some submeter options. And again, this is, I always take a really applied approach, because again, to go into a property and just say, ask them to drop a big dollar or change their routines is very difficult for them and very disruptive. So really just depends on the property and the goals. So can you use the existing submeters? This is a great way to get started. We'll look at some case studies where we've done this. Do they have submeters they're not using? Do they have submeters that they're using, but it's not giving them actual information? They're just kind of writing it down. So what are some, can we use the existing submeters? Can we connect them to some kind of reporting system? Maybe it's time to put in new meters, right? We want to put in new meters. We have something specific we're looking for. Maybe the facility was built without submeters. You just don't know. So there's lots of options for submeters now. It has just gone bananas in the past few years, it feels like. I am madly in love with clamp-on meters. There's a whole bunch of those these days. There's different metering technologies that will run the whole program for you. So we'll look at some different ones. We'll get more in depth on that. Or do you have some kind of combo? Do they have an existing meter for one part of the process, and maybe I can add a second meter for the other part and combine that information to make more sense? So really just depends on your budget, but you can get pretty far using existing meters. So let's take a look at that. Okay, and so kind of the last to wrap up this kind of overview, data management. It's all about data management. A lot of times I see people with even high resolution water use, and it's just like, what does it even mean? So kind of at the preliminary level, especially if you're going to be using existing meters, you're going to run into a lot of handwritten forms. I go to a lot of hospitals, banks, that they are doing their best to collect data, but a lot of it is handwritten, which is great. That means that the routine is there, so all we got to do is improve the routine, but it's very consistent. So basically added benefit with almost no additional work. So do everything you can to transition to electronic. We'll look at a couple of case studies. And try to eliminate double entry. So I see a lot of places where people record the information and they give it to somebody else puts it in the computer. There's just such a delay in getting the information, and it's so many mistakes in there. We're going to look at a case of basically try to include automatic calculations. Once I enter it into electronic, be it like maybe a form, an Excel sheet, whatever you're going to use, when they enter the data, have it, like if it's a meter, it immediately calculates what the use is from the previous read. And be gentle. This is a scary transition for people, especially if they're not techie. Even going from writing it down to entering it onto a screen is just scary. It's new. So absolutely plan to iterate. So if you get an idea, you want to make the switch, talk to people and plan to go back and fix any tiny little thing that's a problem, because that for them is their daily job. And so something that you might not find inconvenient will be very inconvenient to them. So it's really, they're the customer. So whatever we do when we switch from handwritten to electronic, we want to make it very easy for them. Okay, next, as we get into these more advanced systems, we're going to do we're going to install, some submeters that are going to report to a dashboard somewhere, or something that's not handwritten or manually recorded data. Shared drives are great if you're going to swap from handwritten to electronic so everybody can access it. Would encourage you not to have it on one person's device. Some programs will provide, there's some clamp-on meters out there now that connect to Wi-Fi. So that's great. That sometimes can be challenging in a commercial property because it can be a security risk. So absolutely make sure that you can access the Wi-Fi before you make that recommendation or purchase that equipment. And work with your IT team to see, like, is this possible? Most of what I see is basically a cellular or radio to cellular. So you might have different metering locations around the property. They transmit in radio to a gateway, and that gateway sends it all through cellular connection to the cloud. That's nice because it's basically out of everybody's way. You don't have to worry about the security risk with Wi-Fi. And the gold star really is if you can connect to the building management system. Hopefully at the end we have time for a case study on that, but that's already an existing routine. If you can connect those meters to the building management system, people are already looking at it, they're already used to that, and make that information come alive in there. Those are basically kind of the range of what you're going to see. And then what is the communication? Do I want real-time data or do I want daily? I personally prefer the daily reporting because real time, nobody likes to be running around trying to put out fires. And these property managers, operations, they already are doing that every day. So I like a daily report. I see it, I can put it into my routine. I know what's going on. But, real time is certainly nice if you have an actual broken pipe or something, not just a, broken valve. Are you going to get alerts? If you are going to get alerts, how are you going to get those? A lot of facilities folks that I work with don't do a lot on email, so maybe text is the best way. And alerting is great. It's really great. But the number one thing with alerts is that if it's too much, it just gets ignored. I myself am guilty of that. If I get an alert every day, I just stop looking at it. So really fine tune those alerts to where, boom, when it goes, it is really meaningful. And then 100% establish an alert response. Because if every time you get an alert, you're like, what do we do? Just have a routine. A lot of times, we'll look at a case study. Sometimes it's just very simple. So you get an alert, have a path that you go, establish a routine that goes from easy first, then you can get into the more complex. But just, this is it, part of our standard. We get an alert, we verify basic, and we're going to start this routine. And so 100%, as usual, training always helps. Nobody can just know things without being trained. Okay, so let's look at a couple case studies. So this is using existing meters. This was a property that was a hospital. So this is one example of a data entry form. So they had 5 forms, and they walk around somewhere between every 2 hours and every 3 hours, depending on the form, and they write down all this information. So I was like, man, that is amazing. That is like real-time data entry. A real-time manual data entry, but it just gets written down, filed away, written down, filed away, written down, filed away for years and years. In fact, when we looked at it closely, we realized some of the meters weren't even recording. And so, working with their team, a really great building engineer that was willing to work with me on Excel. So we got a tablet, we made a user-friendly Excel form that combined all of the forms in one. It was protected, so nobody had to worry about fat fingering it. They would go in, same routine, and just enter it manually. So instead of going from writing down a bunch of data, we had to do automatic calculations. So boom, now we got everything. We've got boiler water use, we got our cooling tower water use. Not only that, we're looking at the efficiency of the cooling tower, right? So this is all just automatic calculations that are built in. All they need to do is their normal routine softener use. So now we can start seeing trends, problems, things like that. So same routine, much more information now, existing meters. Okay, can we connect to the existing meter? This is called a VNR. I use the heck out of these things. It's by a company called Metron Farnier. So it will connect to a lot of existing meters. So this is just a pulse output meter from a cooling tower. So this one I was able to connect. This is just a little cable, puts out a pulse every, I think it's every gallon on this one. And so this will record it, boom, transmits it once a day through cellular, magical cellular into the magical cloud in the sky. And we'll look at some of this data. But that's super easy, affordable, and keeps everybody on their normal routine. Oftentimes I'll pair these with a clamp-on meter for the cooling tower blowdown. Okay, so I can't use existing meters. What kind of permanent, what do I think about if I'm gonna install a permanent meter? Well, it's a good choice if you can do it, right? So they're high accuracy, they're gonna be more accurate than a clamp-on meter, but it does require pipe modification. So it's just the trade-off. They're affordable, they're a lot more affordable than clamp-on meters or there is typically not a real straight pipe requirement, right? You can kind of put them where you need, and but they're not usually typical for high temperatures. So I say this because I've had a couple of boiler projects lately trying to meter boiler condensate. So these go up to about 120 degrees, which is not going to be enough for a boiler condensate. So just things to consider. Am I going to put in a permanent meter? But do not forget, especially with cooling towers, the right meter for the right system. So you need to have that technical knowledge. So this is a cooling tower blowdown system. Here's the blowdown valve. So there is a water meter in this picture. Can anybody find it? I'll give you 3 seconds. It is right here on the ground. So it used to be here, but they were having so many problems with it clogging up because what do you have in blowdown water? It's an open system. You're going to have really high mineral concentration, dirt, twigs. There's one place that I work that every time that the grounds guys mow the lawn, the filter clogs up full of grass. So with cooling towers, I never put anything in the blowdown that has anything in the channel. So it basically always has to be ultrasonic. So these guys just finally got so tired of dealing with it clogging up, they just took it out. So right meter for the right system, whatever it is you're dealing with. Okay, so here we are with clamp-on meters. Again, I love these, they're so convenient. Here's a clamp-on meter on a cooling tower blowdown, and then the brains are up here, so pretty out of the way. So nuances with these. They require a full pipe. The pipe has to be full, so you have to be upstream of a valve, right? So the blowdown valve, you can't see it here, is down here. So that pipe is always full. The system comes on and it's reading flow and then it closes, but the pipe is not empty because it's sending a sound signal through there. It's ultrasonic. Most of them require a dedicated power supply, so that can be really limiting in irrigation. So both the straight pipe and the power supply can be limiting in irrigation, but they're super convenient. This one is actually at a hospital and they have a bunch of them and they love them because they just move them around. So if the cooling tower is shut down, they got all these, they can go put it on other water lines and processes and see what's going on. So that's very convenient. They do need the specs are a 5 times pipe, straight pipe diameter, 5 times pipe diameter, upstream and downstream. We'll look at that. So that's good to know and something to consider, but I'm just a big fan of testing it first because they work pretty good in most situations, but more or less that is the requirement. And then some are suitable for high temperature. The bigger ones can go up to almost, I think, a little over 200 degrees, and smaller ones, you just have to get a kind of a way to separate them. They make high temperature clamp-on meters. So that's very nice, especially for a boiler blowdown or boiler condensate return. So as with all of life, there's trade-offs, but those are kind of the main nuances. So with talking straight pipe requirements, so here is a blowdown system. This is the main condenser line, and then coming right off of it, it goes into the blowdown valve. So I really wanted to meter the cooling tower, but there's no way to do it because I don't have enough straight pipe where I can even get the meter clamped on. But things can be solved, so they were able to modify it. So it's coming off now. They just put in basically a U, upside down U, and so now my meter is clamped on right there. So it's usually very, not very complex plumbing, especially if they have plumbers in-house. So that's one example. It's just, basically you're not dead in the water if you don't have it right away. You just might have to do a little pipe modification. Here's another one I thought was very clever. It's kind of hard to see, but this is the main condenser line. So the line comes off, and basically, again, I had no enough of a straight pipe to, by the time it came through this blowdown valve. So this one, they changed it, came off. So here's my meter right here. And so you can modify it pretty easily. So if you don't have the straight pipe, typically you can find it. If you are on a drain after the valve, same thing, you just have to put in basically a U-trap. And so even if the pipe isn't under pressure, that trap will always be full, and I've done that a lot. Okay, so I'm always telling people you got to get in the field, you got to try stuff. If you're really going to know how these meters work, you've got to got to try it and see for yourself. So on this one, the specs are going to say, you have to have that straight pipe diameter. I believe this was a 1-inch line. So in theory, I should have, 5 inches upstream, 5 inches downstream. So this again is coming right off the condenser. So boom, I'm right into a 90, and then I'm right into another 90, and I had this teeny tiny spot to put a meter, because then here we are with the valve. And so again, if you can get by without pipe modification, it's going to move the project along a lot quicker. So I was like, you know what? I'm just going to try it. So clamp it in. So right here is a stability indicator. And so that's going to say, well, how stable? Because what those clamp-on meters are looking for is basically laminar flow. You can't have a bunch of turbulence, because then that sound signal gets thrown off in there. So the most bars you can have is 4, and this thing is running at 17 gallons a minute for the blowdown, and I got 4 stability bars. So boom, I am good. So the requirements are good, but get out there and test it and see, is this actually going to work for me? Because it probably will. There's only been like one time when I have not had it work. Okay, so let's look at some case studies for some the water use areas. So let's go inside. So here's a project. This was basically additional new meters with a manual data entry. So one of my favorite people, Mike Peck. This was a facility that had 7 water-cooled condensers for the IT closets. So he said, hey, I was doing cooling tower project. He's like, hey, can I borrow one of those? I want to put it on these water-cooled condensers and see how much water they use. So within 1 month, they were able to collect enough data, and they replaced 4 of them with water-cooled systems, so that's good. And the remaining 3, we installed meters on, clamp-on meters. You can see it right here. So every day, normal routine, he would walk the facility. I just made a Google form that he could, Google sheet that he could enter the information on his phone. So what we were doing, so he would put in the meter read, it would automatically do the calculations. So now we're getting this daily total water use for these condensers. So what we can see here is the green, the orange is really high, this closet 14, and then there's a blue and a gray. So I was like, man, that one closet uses so much more. Wow, it just must be quite a heat load. That is because I'm a knucklehead, because I get a call one day and he's like, hey, I was thinking that is way too much water compared to the other one. So I had my guys basically inspect the valve. It was installed wrong. And so boom, able to fix the valve, which seems obvious in hindsight, and drop the water use way down. So this was just him walking around every day, putting it in to a Google sheet that did automatic calculations. So not only were we able to see where the problem was, we were able to verify that it was repaired. So awesome. So here's a quick tutorial on, this is an ice machine, a water-cooled ice machine. So this is a high-resolution water signature on the top. This is my gallons per minute. And then this is the time, and the x-axis is the time of day. The bottom one is my gallons per hour, right? So this is 1 day. So this basically, the top one is like the heartbeat, the EKG of the system. So basically, this is how a water-cooled system should look. The system needs to be cooled. The compressor comes on. It's cooling the space. Boom, I've got water flow to cool off the condenser. Compressor comes back on. Water starts running to cool the condenser. So this is what a normal water-cooled system should look like. On and off, on and off, on and off, as it needs to remove heat. So let's look at this is another water-cooled system. This is for refrigeration units in a hospital. These are water-cooled condensers. So we clamped a meter on these, and I can see this is 1 month now. It says resolution has changed. This is still my gallons per minute. Now we're into gallons per day. So this thing is just running completely straight, meaning the valves are failed. There's a bunch of troubleshooting ways you can see that without metering it. We won't get in that today, even though, so I know right now I have failed valves, and I've been there, so I know that all 5 of the valves are just failed. So it means it's just running all the time. So not only do I know that I have a mechanical problem, but now I have the information that I need for a payback, because these things cost almost 6,000 gallons of water a day. Now in this particular location, the water is very inexpensive, but I say, okay, that's about 1.5 million gallons a year. Now I can start saying, well, I could probably save 80% of that just by I'm operating correctly. So if we can repair these valves for about $1,000, my payback is 2.2 years, and I'm going to save about 4,600 bucks. Or maybe we want to replace them, same information to replace them, but we're looking at about a 13.6 year payback period to compensate for going into water cooled, or to switching from water cooled to air cooled. So just depends. That's not my decision to make, but that does give them the information that they need. This is a case study. Very big thanks to Wint. They are a water management company that does submetering and has a whole data management system behind it, or a data management dashboard, and great customer service, because they'll give you a call on the phone, which is awesome. Because again, alerts are great, but where are they going, who's getting them, and what do they really mean? So they were kind enough to provide a case study here from a toilet, clogged toilet. So basically they got an alert, and this one was on the 3rd floor, which is why I love this case study, because they put meters on each riser, basically. So submetering is great, but if I got 20 floors and I think I got a constant flow, that's going to be quite a trip figuring it out. But this one, they have it on the 3rd floor, so they got an alert about 250 liters per hour. So that's about a gallon per minute flow. Ended up being a toilet. But the fact that they're metering each floor is so much more helpful than if you were metering the building as a whole. So thanks, Wint. There was a question ahead of time, so I just threw this slide in regarding multifamily. Multifamily is tricky, right? Because you could meter everything. You could meter every single piece of equipment, every sink, every toilet, anything in a building, but it's cost and data management. So this isn't a meter per se, but I've heard good things about it. I've never used it, but this is called Sensor Industries, and they basically, for multifamily, you include the sensor on each toilet, and it's not really a meter, but it's a flow sensor. So it will tell you, okay, you have unexpected flow, so you can pinpoint leaks much quicker in multifamily, right? Because it's difficult. You're not going to be going in and getting into the facility, or into each room each day. So that's a good solution for commercial. And again, that's pretty much what you need. Is it running constantly or is it not? Okay, here's a good one. So this one is for, again, this was a hospital. This is on the chilled water line. So this means it's a closed loop water line that's going through the building, picking up heat and giving it to the, and exchanging that heat in the chiller to give it to the cooling tower. So right away, what do I see that's wrong? Again, we have our gallons per minute. This is day down here. So chilled water line, you should actually never have water flow, maybe a little tiny bit of makeup. So this was all of a sudden a really big, basically in this amount of time, it was basically like 20,000 gallons a day water flow. And I was like, oh my gosh. So we're thinking there's a leak. They're running around trying to find it. Like, what is happening? But as I say, always have a routine if you have a leak, because first thing you should do is just walk the line, whatever the line is. So after looking for it for an extended period of time and trying to contact like leak detection agencies, because we were thinking it was underground, the engineer walked the line and found a valve that had been left open, a manual valve that had just been left open in some dark corner for some bizarre reason. So on this one, an alert, I don't need to even know how much water I'm using. I just need to know I'm using water, right? So this is an example. This isn't the right date. It's just I had to go back in my records. But that's, I don't have to ever think about that closed loop until I get an alert that just says, if you have any water use, I know I have a problem right there. So this was a good one. Okay, let's move into outside. Okay, so this is basically moving from, okay, I can get irrigation water use, but what does that really tell me? And this would be more for like probably more of a manager, but we want to monitor the performance, not necessarily just the water, because irrigation water, it's going to change from year to year based on temperature, right? So just because you use more one year doesn't mean you're a bad human being who wasted. Maybe it was just hotter. or just because you use less one year doesn't necessarily mean you've done any savings. It probably was just cooler. So this is a great program, very popular in the Southwest, called Waterfluence, but they basically calculate a water budget. So the green is the expected water use for the property based on landscape area, vegetation type, and local climate. It's all irrigation science, very standard stuff. And so every month they populate that, and then typically cities are the ones who provide this service. The city will provide the water use information, which is the blue. So anything in between is waste. So this is nice for management to get, very visual. I've got my stats up here. So these guys are using about 2.5 times what they need. They had a big leak here, but we were working with them. It's getting better. So they are making improvements. So this is a great way to make information make sense. I also think with irrigation, if you can get gallons per square foot, that's nice. So here's a property, especially for cities or people who are always harping on irrigation people. Sometimes it's nice to just show that you're doing a great job. So a lot of times with parks, golf courses, people are like, they're so wasteful, blah, blah, blah. This is a golf course in Spokane, Washington. And look at these guys. They are right on budget. So when people complain, I'm like, actually, they're so efficient. When you golf, just relax because you are golfing on the perfectly watered golf course. So sometimes it's really nice just to let people know that you're doing a great job, to have that information, and also to see a good investment. Same program, this was out of Arizona. Again, big water waste here, and then a smart controller was installed, and boom, they just were sailing right on budget. So all of these things are helping us capture information to monitor, to show what we're doing. Okay, here's a good irrigation. Here's a little bit of a multi-step case study. Big campus, main meter, and then there's 3 or 4 buildings, all with each their own irrigation system. So you're never ever going to find anything with the main meter. So this is in one of the buildings. The water, I kind of had to piece this picture together from 2 other ones, so it looks a little bit weird. But basically, the water is coming in here, goes into the building here, and then, oh, I think I've got an arrow, comes in through the irrigation system. Here's our backflow, and then we put a clamp-on meter here, right? So we're like, what's going on with the irrigation system? Okay, so a couple of things to note here with high-resolution data. So this is 2 different irrigation systems on the same line. So I can see a couple of things right away. First, look at the difference between these 2 profiles. So the first one is an irrigation system that has, a controller that has the ability to put in 5-minute delays or any kind of delay between each zone. So if you can do that with high-minute resolution, boom, I can see what each zone is running, how it's running, how long it's running. I mean, it is just perfect, nice little profile. Versus here, I can see that there's something going on. You could try to piece it apart, but it's just, it's still useful as a bulk, but it can be, finer resolution. So that's really helpful. Again, here's one where there was a irrigation, 5-minute delay between each zone. So this is normal operation, and then boom, I can see basically the valve failed on this zone. So I see that, I'm like, psh. I send my folks to go out to whatever zone that is, 12, and fix the valve there. So it can save, let your fingers do the walk-in, kind of save some time, and then verify that the fix was made. Okay, so this is the same facility, life's going along, and then all of a sudden we get this basically increased flow. So I'm like, okay, looks like I got a leak in the irrigation system. Kind of an odd one that it just started, but so that's continuing on. So I'm monitoring it and I see, oh, the leak stuff. So I call the maintenance guy and I'm like, hey, did you guys find the leak? Or I thought it was just a whole bunch of leaking valves. And he's like, no, the system shut off. So we're working on it now. I'll let you know when it comes back on. So it comes back on here, but what did we notice? So I'm like, oh, well, maybe it's something besides the valves. But we go out and we look, and the valves, I swear, they were worse than they were before. One was stuck completely on. The other one was leaking worse. So that was like a service provider. Maybe, I'm not sure what happened, but the valves definitely did not get fixed. So that was nice to see that, because normally you'd be like, go fix the valves and think it was done. So continue on. Here we are, beginning of October. Again, I see a big water drop. So I'm like, okay, did you guys find something now? He said, no, we totally shut the irrigation system off. And I'm like, oh, well, interesting, because you've still got water running. So we go back, we open the, we test the backflow, and it does still have pressure. So basically this gate valve here had not closed all the way. So even though the system, they turned it down, wasn't closed all the way. In this picture, the ball valves are closed, but this was after the fact. So they were able to close the ball valves and verify that the system was off, but that would have basically been running water into the irrigation system all winter. So on here, we can see that my stability is really low, and that's because it's not a full pipe, right? It's just barely leaking water through. So I didn't necessarily need the volume here. I just needed to know that there was any water running at all to know that there was a failure. So not perfect, the water use may not be accurate, but it was enough to let me know I had a problem in this case. Also for operational issues, this was a property that was doing some overseeding. So again, very high flow. This is one day about 63,000 gallons a day. So I can see by this signature that it's just the same program running over and over and over and over and over, which you do need to keep the ground wet with overseeding, but I think this was a mistake. And this went on for basically, well, about 3 weeks. So that's like a good operational catch. You'd be like, wow, there's a lot of water. You can just go in here and see. And this stuff happens all the time. It was hard to pick case studies. This is another great one from Wint. They, same thing, they were able to, they got an alert and for the irrigation system. They gave the facility a call, which I love that. Again, it's so much more. A lot of times that's what I'll do. If there's an alert, I'll just give them a call and say, hey, this is what I'm seeing. But an automatic alert is fine also. And so they were able to go out and find the burst irrigation line and get that fixed. Okay, now my favorite, cooling. So this is an example where we have a meter combo. There was an existing meter, they had a makeup meter, but they didn't have a blowdown meter. So again, be very careful with what meters you use on blowdown. I always use ultrasonics, so the clamp-ons are great. But again, made a form where they just had to select the day, put in the makeup meter read. It would automatically calculate the use since the last one, and then they would enter the blowdown meter reading. So that part of their normal routines just updated the form. So it gives me water use information, which is great. That's what I want. But is that really helpful? I mean, it would tell me if I had something really crazy, but am I running efficient? I don't know by looking at this. How hot is it outside? How am I going to know? So we can take that same information, do a simple calculation, makeup water divided by blowdown water, and boom, we have our cycles of concentration. So now we say, okay, really my cycle's goal is 4. Anything above 4, like above 5, I probably have a mechanical failure, like maybe a stuck open or a stuck closed blowdown, maybe some overflow, or anything below 3, again, maybe a mechanical problem, like maybe my blowdown valve is stuck open. It's going to drop that efficiency. So we have gone from like basically no information to now I can basically tell the efficiency of my cooling tower every day, all part of normal routines, just cost 1 additional meter. And so my favorite part. So with cooling towers, again, with irrigation, we want to, just like irrigation, we want to monitor performance, not water. I have worked with so many facilities people that get so frustrated chasing water use around because what if it's hotter and that year and you need more water? What if the load is higher? What if you had separate cooling tower systems and one went down and now you have more load on the other? You just don't know. So instead of dealing with chasing water use from year to year and day to day, the goal of a tower is efficiency, right? You're never going to get to 0 water. So basically, let's use the efficiency, and as long as efficiency is in range, I don't have to worry about my water use as far as performance, because then I just know that's how much it needs to operate correctly. So we say, what's the target cycles of concentration? This is going to be different on every tower based on water quality, water treatment, operating conditions. Then I'm going to say, okay, what's my low threshold? So let's say my target is 4. If I get below 2, I think something's pretty wrong. That's a pretty big departure. Again, too much blowdown, stuck valve, sensory issue. We're going to look at some case studies, of course. Or if I get above my high threshold, again, I probably have a mechanical. But as long as I'm in between those thresholds, I'm good to go. The tower's just using as much water as the tower is going to need. So this is a dashboard, again, done by Metron Farnier Water Scope. So basically, here's the kind of heart of the program. This is my water use on the y-axis. My date is at the bottom, so this is daily use right now. We'll get into the minute. So the green is my makeup water. The blue is my blowdown. Okay. But, so that gives me kind of good overview. I can start getting some volumes. But what I really want to know is how efficient is my tower running? So on the secondary axis is my cycles of concentration. And my target, which is 4. The red is my high threshold. Anything over that, I probably have a mechanical failure. And then 2, anything below that, I probably have a mechanical failure. And then here's my stats down at the bottom, the makeup, blowdown, and cycles for that time period. So these guys are running at pretty low cycles. Could be an operational setting, could be a stuck open blowdown. But what I know is if my target is 4, now I can start using this information. If my target's 4, and I'm running at 1.8, we'll just round up to 2, and that's about 70,000 gallons for that time period. This is from EPA WaterSense at work. My initial concentration ratio, cycles of concentration. So what I say, 2. If I could get all the way up to 4 here, that's 33% water savings. So is that worth it? That's actually not my call, but I'm going to let the property know, and they can decide. That could be thousands, and that could be tens of thousands of dollars. So then now we have information we need from an operational standpoint, but let's look at some mechanical failures. Okay. Cooling tower, again, they're running pretty good. Their target is 4, anything above their thresholds are 6 and 2. So you can see here at the beginning of the month, they're running pretty good. They have some anomalies here in the middle. And then after that, the service provider came. So something happened in here. Then I'm really low. I'm running down below 1. What else do I notice? My makeup value, my makeup water and my blowdown water are basically equal. So my first thought at this is I'm like, oh, their blowdown valve is stuck open. It's just running a single pass. But let's dive into the high resolution 1-minute data and see, let our fingers do the walking. Oh, sorry, this got an alarm. Again, this is a different date. It's just giving you an example of what the alarm looks like. Just 1 alarm a day sends me an email. I can put it in my existing routines. So look in the 1-minute data. So again, this is a blowdown. The top one is my signature, my heartbeat basically, and the bottom one is the gallons. So this tells me my blowdown is working. It's not stuck open, right? It's coming on and off. So here my blowdown is running, then it turns off, then it's on, then it turns off. So it's not a mechanical issue with my blowdown valve, but something is telling the tower to blow down all the time. These are incredibly long blowdown times. So what does it have to be? The sensor. So I was able to go to the site, verify this is the conductivity reading from their tower, reading at 1,232 microsiemens. My sensor, which I always carry a standard with me so I can verify my conductivity pen is working correctly, is 682. So basically their sensor was reading twice as high. So probably just a miscalibration, but that was causing it to blow down constantly. So that's a water waste event that we were able to capture. Here's the opposite. This is probably a scale event, right? My cycles is too high. So again, I can see my high threshold is 5, but I'm pretty much running above that all the time, basically a cycles of 7. So we don't want water waste, but we don't want scale, right? We in fact probably want scale less than we want water waste because it's much more expensive and damaging. So again, I'm going to go in and look at my high resolution. And so I say, okay, I can see my blowdown is working, but it's just not giving it doesn't have enough blowdown. So I'm going to verify it. So again, this is the tower cycling up, boom, tells it to blow down. Tower cycling up, reach my set point, it blows down. So I know that's working, so what could it be? As usual, not as usual, but so I go and I look at their controller. Their controller is registering a conductivity of 3,400. But when I sample it with my pen, now this is the opposite. It's actually at 66,000. So this is going to do the opposite. It's going to say, I'm not blowing down near enough. And so that basically, you see sensor failures all the time. So all that tracking just helps me verify what the problem is pretty much right away. Here's one more. Again, a really low cycles. And basically, this is the blowdown right here. What did we see in that last one? It should be coming on, coming off, coming on, coming off. Boom, I know right now, without even going to the site, that my blowdown is stuck open. call the service provider, let them know, and they can go from there. This bottom one is the makeup. And again, this should be responding every time there's a blowdown, but everything's just pretty much wide open. And so going to the site there, I like to always go and capture the information to put it to a case study to share with you wonderful people. But again, my conductivity was reading, sensor was reading 2,000. My sensor was reading 23, but that's not even my concern right now. My set point is at 36. So despite this 400 microsiemens discrepancy, the tower shouldn't be blowing down at all. It's just a stuck open blowdown valve for sure. And this was just another one where the alarm was set below the set point, so it was in constant alarm. And then this is kind of cool. This is from Wint also. So they do their cooling tower metering a little bit different, monitoring. So theirs is basically AI. It's intelligent. It's learning. So what they do is they have a 30-day initial kind of learning period that the software learns the water use pattern of the cooling tower, and then they establish an algorithm that'll give them an alert if there's basically like an anomalous flow, an unexpected flow. So these guys are on this tower. You can see on the 17th, they have this predicted flow, and then they get this much higher use, which is inconsistent with what the learned pattern of the tower is. So that would send an alarm also. So they were able to resolve that. So I thought that was pretty cool. That's well beyond my level of expertise. But so there's lots of systems out there that will provide different services, different metering styles. Let's see how I'm doing on time. I got a couple other case studies. Oh, we got 4 minutes. So I'm going to continue on through another case study because I think we've got till 11:50, and then we'll take some questions. I'll come back to this slide if you want my contact information. Let's actually zip through these, and I'm going to show you one. So this is one that's interesting. This is a company called Alert Labs, really useful. They you can clamp these or strap these devices on the outside of an existing meter, and it's going to give you real-time 1-minute resolution data. So again, these report to a gateway, and the gateway reports to the magic cloud in the sky. So this is a property, they're monitoring their water use. So this is kind of what the dashboard looks like. So their algorithm is detecting a leak, and they're saying the leak is about, or constant flow, likely a leak, is about 7 gallons per minute, 20 liters per minute. So at 7 gallons per minute, so we're chasing that down. So we look around, we can't find it. So we're gonna use a clamp on meter to start trying to find it, because this property is huge, it's a huge hotel. There's just no way to get in every place we need to. So we're looking at a bunch of different pipes. This one goes, we see for basement, first floor, kitchen, and I know they have some water-cooled condensers. So like, well, let's start there. So we were able to just quick diagnostics, clamp on the meter. It's reporting through cellular connection. So I can put it on. I don't have to go back to the facility. And voila, we see that we found basically approximately 3 gallons a minute constant flow. In this, this is over a period of a week. But it's just constant, so that's 3 gallons a minute. But what's great is we were already metering the cooling tower at this location. So that's going to give me an alarm. And so these are the types of alarms for this process or this service, but again, they come different. It's going to basically say water's being used most periods of the day. That's useful for that water cooled, right? Because it should be turning on, off, on, off. High flow for hours at a time, or basically it's looking like a leak. So these are different algorithms you can set in this water scope dashboard, set these parameters, and it'll give you these alerts. But again, we were already monitoring the cooling tower, which is nice. And so we're seeing the cooling tower is running at about 4 gallons per minute because it's also having a problem. So we got 3 gallons a minute, we got 4 gallons a minute, so we got 7 gallons a minute. So we basically have found our problem. And so they may want to install a permanent meter on that line so they can keep track of it, or maybe this was good enough and we can move on, but saved a ton of time. So it basically took us, a couple minutes to install the meter, and now we can isolate it to a location, and we're going to go find it. I'm pretty sure I know what it is, though. Again, here's a clamp-on meter used for irrigation. Here's their irrigation system. This is a huge campus, this is a big hospital. So putting in a dedicated irrigation meter, all that, is can be very expensive through the city, but they were able to just clamp one on. And now I have my water use and I can start working on what's going on there. At least I know what my daily use is. Now we can start working on our own water budget. Okay, so I'm going to go back to the conclusion side because I'm so on time, which almost never happens. So